9.5 is about hyperbolas. So let's start with the definition of a hyperbola. A hyperbola starts with two foci. And a hyperbola kind of looks like a double parabola. So if you choose a point on either of those curves, so let's say I take this point, and then you find the distance to both foci. So that is the shorter distance. This is the much longer distance. If you subtract them, so you take the long line segment minus the shorter one, that difference is always the same on either of the curves. So you choose any point on either of the curves. So let's say I choose this point instead, right here in yellow. Well, I find the distance to the further away focus, and I subtract the distance to the closer focus, and that difference will equal the same thing as the first difference using those red line segments. So wherever you go on either of the curves, you find the distance to the two foci, that difference between those two distances will always be the same. All right, so looking at the equations, they are very similar to the equation of an ellipse. The major difference you can see is there's a minus here where there used to be a plus for an ellipse, and then the equation relating A, B, and C now has a plus in it, so it looks like the Pythagorean theorem again. All right, I think we'll talk about that other stuff when we start graphing them. Let's start number 1. All right, so we can see that the hyperbola has one curve that opens up and one that opens down. So this is a vertical hyperbola. We also can see that the midpoint of those two vertices is at 0, 0. All right, so it's vertical. It's centered at 0, 0. So we could go ahead and write y squared. We don't need any parentheses because it's centered at the origin, minus x squared. And we'll figure out the denominators now. All right, so from the center, it goes up 3 to get to the vertex, or you could say it goes down 3. We square that distance and we get 9. All right, now they don't give us the co-vertices, but these points inside those curves, those are the foci. All right, so because we went 3 to get to the vertex, A is 3. The foci are 3 rad 5 away from the center. And so now we just have to use this equation to figure out what b squared is. So a squared would be 9. 3 rad 5 times 3 rad 5 would be 9 times 5. Right, so b squared is 36. So 36 goes there. So unlike with an ellipse, A had to be bigger than B. With a hyperbola, A could equal B, A could be bigger, or B could be bigger. All right, number 2 is another vertical, and it's also centered at 0, 0, because if I take these two vertices and find the midpoint, it's 0, 0. So let's go ahead and start with y squared over something minus x squared over something equals 1. All right, so those dashed diagonal lines, those are the asymptotes. And so the slope of the asymptotes of a hyperbola, it depends. Sometimes it's plus or minus b over a. Sometimes it's plus or minus a over b. The way it works is slope is rise over run. So if it's rise over run, you always want to look underneath the y first. So in this case, it would be a over b. But over here, since again slope is rise over run, we look underneath the y and we get b. We look underneath the x and get a. So I guess what's easier than remembering if it's a over b or b over a is just take the number under y, take the square root, that goes on top, and then the number under x, that square root goes on the bottom, because slope is change in y over change in x. All right, so looking at those lines, you could just count the slope. So if I'm choosing some nice points, so from the center to this point here, the graph goes up 3 and it goes over 5. Because this is a vertical hyperbola, we note that the slope has to equal a over b. Looking at the graph, we already have a. From center to vertex, that's a, and that's 3. So that's pretty easy to solve. If you know a is 3, then b has to be 5. All right, so again, we said a was 3, which makes a squared 9. B is 5. So b squared is 25. All right, so after you find the slope, 3 over 5, that does not necessarily mean that one of a and b is 3 and the other is 5. It could have been that a was 6 and b was 10, so be careful of that. Sometimes it reduces to the slope, and we'll see that right now on number 3. All right, so on number 3, we have a horizontal hyperbola, and this one is not centered at the origin. It's centered at 1, -2. All right, so we're going to start with x minus 1 squared. We'll figure out what goes underneath that later. Minus y plus 2 squared over something equals 1. All right, a is easy to find. If we go from center to either vertex, that is 2. So we square that. A squared is 4. And then we can see the asymptotes. So using these 2 points, the slope of the asymptotes is 2, or 2 over 1. All right, that's going to equal, this time that's going to equal b over a, because it's a horizontal hyperbola. And we already found that a was 2. All right, so on this one, we get 2 over 1 equals b over 2. You can cross multiply and get that b is 4. B squared goes underneath y, so we square that to get 16. All right, I need to teach you guys some more vocab. So going back here, we don't have a major and minor axis anymore, and I'll do it on this one. So the line segment that connects vertex to vertex, that is called the transverse axis, and the length of that is 2a, because from the center you go up a and down a, so the total length of that would be 2a. The line segment that connects covertex to covertex, the length of that is 2b, and that is called the conjugate axis. All right, so I'll draw the same 2 axes on this one. So again, from vertex to vertex, that is called the transverse axis. It has a length of 2a. From covertex to covertex, That's called the conjugate axis and has a length of 2b. Right, so for number 4, we get the conjugate axis has a length of 6, so we could say 2b equals 6, so b equals 3. All right, looking at the vertices, those vertices are up and down from each other, so this makes it a vertical hyperbola. The midpoint of these two numbers is 0, 0. The midpoint of those two coordinates is 0, 0. So it's vertical because if you graph 0, negative 4 around here and 0, positive 4 there, you can see they are vertical. All right, so it's vertical, centered at 0, 0. We start with y squared over something minus x squared over something equals 1. We already found that b was 3, so this is 9. From 0, 0 to either of those vertices is 4, so we square that to get 16. All right, on number 5, if you graph those points, you see that they are side by side. So this is a horizontal hyperbola. It is centered at 0, 0 because the midpoint of the two vertices is 0, 0. So it's going to be x squared over something minus y squared over something equals 1. We can see that from 0, 0 to either of these would be 5. So we square that to get 25. All right, the foci is c units away from the center. So c has to be rad 26. We plug into this equation to find the only one we're missing, which is b squared. A squared is 25. C squared is 26. So b squared has to be 1. All right, center of these 2 points is 0, 0. We can see how far away the vertices are. So that's our A. Over here, the foci is rad 5 away. All right, so let's do this formula first. 4 plus b squared equals 5, so b squared has to be 1. All right, those two vertices, 0, 2 and 0, negative 2, those are on top of each other, so this is another vertical. So we do y squared over something minus x squared equals 1. A was 2, so a squared is 4. B squared was 1. So here's our answer. Now we're going to practice graphing some hyperbolas. All right, no parentheses in the numerator means this one is centered at 0, 0. All right, so we see underneath y, there's a 16. Take the square root, we get 4. And because it's y, we go up and down 4. Underneath x, you see a 4. Take the square root, you get 2. So we're going to go left and right 2. Right, now we're not going to make an ellipse using those 4 points. We're going to draw a box first. All right, and so the reason we draw a box is because the diagonals of that box represent the asymptotes. All right, so I'm going to try to draw some diagonals that go through the 2 corners. The slope is 2. All right, so I'm going to try to make sure I stay on the path with a slope of 2. And then the slope for the other asymptote is negative 2. All right, so try to draw diagonals that go through the corners of the box and continue with that same slope. All right, and then we have to figure out, is this horizontal or vertical? It is vertical. All right, so you don't have to make a table. You can just start, because it's vertical, start at the top of the box and then draw what looks like a parabola that gets close to the asymptotes. Right, remember, asymptotes are lines that we want to get close to but not touch. And then another one on the bottom. So start at the bottom of the box and then get close to the asymptotes. All right, they also wanted us to identify the vertices. All right, so you could see those were at the top and the bottom of our box. So we have a vertex at 0, 4, and another one at 0, -4. The foci. All right, so the foci are not graphed, but they are C units away from the center. And so C is going to be 20, or C squared is going to be 20. So C is going to be 2 radical 5. Square root of 20 is 2 radical 5. All right, so we're centered at 0, 0, and this is vertical. So from 0, 0, we're going to give 2 rad 5 to the y coordinate. And we do plus or minus. So there's 2 foci. All right, so if you wanted to graph those, 2 rad 5 or square root of 20 is between 4 and 5, so they would be somewhere around here. That's where our foci would be. All right, the asymptotes. Asymptotes are a lot easier when the center is 0, 0. All right, so the asymptotes, you can just do y equals mx plus b. And it's just y equals mx because our y-intercept is 0. So the slope was 2, so one of my asymptotes is y equals 2x, and then my other asymptote is y equals negative 2x. All right, number 8 is centered at 1, 2. Underneath y, we see a 1. We take the square root of that, and we go up and down 1. Underneath x, we see a 4. Take the square root. So we go left and right 2. We make our box. The diagonals of the box will be our asymptotes. We can see that the slope of that, if I want to go from corner to corner, would be 1 over 2. And then the other one is negative 1 over 2. All right, this is another vertical hyperbola. So we start on the top of the box and just try to get close to the asymptotes. All right, and we need to find the vertices, the foci, and the asymptotes. All right, vertices, if you look at the graph, the one on the top of the box is 1, 3. And the one on the bottom of the box is 1, 1. The foci, all right, so C, I won't show the whole formula. C squared is 5, so C is radical 5. All right, so we have to give that radical 5 to the center. Remember, the center was at 1, 2. And because it's vertical, we give it to the y coordinate. All right, so we take our 1, 2, and we give and take radical 5. Right, so we'll have two foci. And then the asymptotes. All right, so this one's going to be tougher because it's not centered at the origin. All right, so you can do point slope. Let's start with the one that's going up from left to right. So if I do point slope using the center, that would be y minus, and then my y1 would be from the center up at 1, 2. So y minus 2, and then the slope was 1 over 2, and then x minus 1. And then my other, the downward slope asymptote is y minus 2. It's the same coordinate, only the slope's going to change from positive 1/2 to negative 1/2. All right, so if I simplify both of those, this one, or not simplify, but put them in slope-intercept form, I'm going to get y equals 1/2 x. All right, so I have minus 1/2, but then I have to add 2 to that, so plus 3 over 2. And then this one is going to simplify to y equals negative 1/2 x. Then I'm going to get plus 1/2, and that's also going to get increased by 2. So plus 5 over 2. All right, number 9 is also centered away from the origin. This one has a center of 3, negative 2. It's also a vertical hyperbola. All right, so 4 underneath y means we go up and down 2. 2 underneath x means we go, 4 underneath x, we go left and right 2 because that's the square root. All right, so our box is going to be shaped like a square. All right, we draw the diagonals of the box to represent the asymptotes. All right, it's vertical again, so we start on the top and bottom of the box and try to just get close to these asymptotes. All right, we have to find the same 3 things, the vertices. All right, so I see one at 3, 0, and then the one on the bottom is at 3, negative 4. The foci will be c units away, so I add the 2 denominators. That will give me c squared, which makes c 2 rad 2. And then again, I have to give it to the y coordinate because it's a vertical. So 3, negative 2, and then I'm going to add and subtract 2 rad 2. All right, the asymptotes. All right, so we're going to have 2 of them. They go through 3, negative 2. So if I'm doing point slope, y minus y1, my y1 is 2. Actually, it's negative 2. So I do y minus negative 2, which is y plus 2. All right, so again, point slope is y minus y1 times, or equals m. The m is just 1, and then x minus x1. Right, simplifying that one, I get y equals x minus 5. And so now I'm realizing I could have just looked at it and done mx plus b. Maybe we could just do mx plus b for the second one. So it looks like it goes through a y-intercept of 1, and it has a slope of -1. Right, for number 10, the equation is not in the form we want it to be in, so we're going to have to rearrange it and complete the square. All right, so I put the y's together, and then I'm going to leave a gap, put the x's together. I'm going to move that constant to the other side. All right, first I want to remove the 9 from the y. Leave a gap. Take out the -4 from the x's. I get x squared. 32 divided by -4 is -8x. All right, so completing the square, that first gap, we take -6, divide it by 2, and then square that. We add 9. The second gap, we get -8 divided by 2 is -4. Square that, you get 16. Right, on the other side, to rebalance it, that plus 9 is going to get multiplied by the 9 outside, so we add 81. That 16 is going to get multiplied by -4, so we're going to subtract 64. Right, so it's 9y minus 3 squared minus 4 x minus 4 squared equals 100 minus 64 is 36. All right, remember that the equation, we always want a 1 on the other side, so we're going to divide everything by 36. All right, so we get y minus 3 in parentheses squared. All right, 9 over 36 is 1 over 4 minus 4 over 36 is 1 over 9. So graphing that, we get a center, another vertical one, a center of 4, 3. Underneath y, there's a 4, square root that. We go up and down 2. Underneath x, there's a 9, take the square root. We're going to go left and right 3. Draw the box. Draw the asymptotes of the box. Right, so that's going to have a slope of 3 over 2. And another vertical one. When you get a horizontal one, you'll start on the left and right of the box. You start on the top again. All right, they want the same 3 things: vertices, foci, and asymptotes. All right, so our vertices, see one at 4, 5, and another at 4, 1. All right, our foci. All right, so the quick way to find C is just add the denominators together and take the square root. All right, so our center was 4, 3. So we take the y coordinate and we add and subtract, we're at 13. All right, the asymptotes are going to be I'm going to do point slope, y minus, right, y1 is 3, so y minus 3 equals, and then the slope of the asymptotes was 2 over 3, 2/3, and then x minus 4. Right, simplifying that one, we get y equals 2/3 x minus 8/3, but then we add 3 to that. So 8/3, negative 8/3 plus 3 is plus 1/3. Right, so that's one asymptote, and the other asymptote is going to be y minus y1 equals negative 2/3 times x minus 4. Right, so that's going to simplify to negative 2/3 x. Then we get plus 8/3 plus another 3 makes plus 17/3. All right, so we put the similar letters together, 25x squared minus 100x minus 4y squared plus 48y equals 144. Take out 25 from these two terms, x squared minus 4x minus 4, y squared minus 12y equals 144. Right, that first gap needs a 4 if we complete the square, which means I have to add 100 over here. That second gap needs a 36, which means I need to take away 144. Right, so multiplying here, you get 100. There you get negative 144. To rebalance it, you have to do the same thing to the other side. Right, factoring, we get 25 times x minus 2 squared minus 4 times y minus 6 squared equals, the 144s cancel, we get 100. All right, dividing everything by 100, we get x minus 2 squared over 4 minus y minus 6 squared over 25. All right, and finally, we have our first horizontal hyperbola centered at 2, 6. Right, underneath the x, we see a 4. We take the square root and go left and right 2. Right, underneath the y, we see a 25, so we're going to have to go up and down 5. Right, we make our box. It goes a little bit off the graph. Right, the diagonals of the box will be our asymptotes. Those will have a slope of 5 over 2. And now this time we go sideways, so we start on the sides of the box and just approach the asymptotes from there. Right, the vertices, again, looking at the sides of the box, are 0, 6, and 4, 6. The foci, right, so quickly to find C, you add the denominators together and take the square root. Right, so from 2, 6, we want to give that to the x coordinate this time. Right, and then our asymptotes. Right, it looks like we could just do mx plus b. All right, so slope is 5 over 2, and the y-intercept for the one that's going up from left to right is 1. And then the other one's going to have the opposite slope, And that one looks like it hits the top left corner of the box, so that's at 11. We finish it up with one word problem. Right, so highlighting the important stuff, we see the vertices are -3, 0, and 3, 0. So that immediately tells us that our A is 3, and those are, if you do a rough sketch, -3, 0 and 3, 0 would be side by side. The focus is at 5, 0, so that tells us that our C is 5. All right, and I think that's all we need. So it's centered at 0, 0, because that's the midpoint of the two vertices. We know it's horizontal, so it's x squared minus y squared. All right, we have A, so A squared is 9. We need to find B squared, so we use this equation. A squared will be 9, C squared is 25, so B squared has to be 16. All right, and there's our equation.